Hello my dear students, I warmly welcome you to CS Digital Classes. In this lecture, we are going to discuss about one of the important theorem. So that is, see the statement of the theorem. Let capital G be a group and let Z of G be the center of capital G. Okay, if the factor group Z by Z of G is cyclic, if the factor group G by Z of G is cyclic, then we have to prove that the first group capital G is abelian. Okay, so here we have equivalence conditions, that is center of G and abelian group are both are equivalence conditions only. Why? Because in the center of G you can write Ax is equal to x into A. In abelian group AB into BA. Okay, the two conditions are simultaneously equivalence only. So that is the theorem. By using that center of the group condition and factor group is a cyclic, then we have to prove that capital G is an abelian. Okay, so now you can see here proof. Let capital G be a group and Z of G be the center of capital G. Okay, then to prove capital G is an abelian. Okay, to prove the capital G is an abelian, it is enough to show that A into B is equal to B into A with respect to multiplication for all A comma B belongs to capital G. Okay, why we are taking with respect to multiplication? Why? Because here factor group is cyclic. Okay, cyclic group with respect to multiplication only. Okay, so therefore here the center of group capital G, Z of G is equal to small a belongs to capital G. Ax is equal to xa. This is the equation for the center of the group capital G. Ax is equal to xa for all x belongs to capital G. That means first of all we have to take one element in capital G. With that element we have to make the commutative properties with each and every element in the group capital G. Then that condition is called the center of the group capital G. Okay, so that is Z of G is the subset, okay, of elements in capital G that commutes with every element of capital G. That commutes with every element of capital G. So let I am taking G by Z of G be a cyclic group. Okay, so now we have to prove that capital G is an abelian group. Since we have G by Z of G is cyclic from the statement, okay, so by the definition, if you take any cyclic group, definitely there is one generator. Okay, so then there exists some generator G into Z of G. యాక్చువల్ గా ఎప్పుడు సైక్లిక్ గ్రూప్ డిస్కషన్ చేసినా ఒక జనరేటర్ అనేది ఉంటుంది. క్యాపిటల్ జి అనే సైక్లిక్ గ్రూప్ తీసుకుంటే స్మాల్ ఏనో స్మాల్ బీనో జనరేటర్ అని చెప్పేస్తాం. ఓకే, సో ఇక్కడ ఫ్యాక్టర్ గ్రూప్ అనేది సైక్లిక్ గ్రూప్ గా చెప్పాడు. సో తీసుకునే జనరేటర్ కూడా సైక్లిక్ గ్రూప్ ఫార్మాట్ లోనే ఉండాలి, ఫ్యాక్టర్ గ్రూప్ ఎలిమెంట్ లాగానే ఉండాలి. సో దేర్ ఫోర్ G by Z of G అనేది సైక్లిక్ అయినప్పుడు, సో దెన్ ద జనరేటర్ is also exist in the format of G of Z of G such that this is the representation. Okay, cyclic group representation. Okay, it is generated by G of Z of G is equal to G by Z of G. Okay, let A comma B any two arbitrary elements in capital G, then there exist two integers small I and Z. Okay, then according to the given condition you can write A into Z of G. What is the given condition? Center of a group G and cyclic group condition. We are using these two conditions. Okay, the left hand side is the center of the group G and the right hand condition is the cyclic group condition. Okay, so therefore A into Z of G, where A belongs to capital G and I is the any integer and this one is the cyclic group. Okay, generator. So therefore A into Z of G is equal to G of Z of G whole power I for some I. Next, for second element in capital G, B is an element. B into Z of G is equal to G into Z of G whole power J for some J. Okay, so this step you can write, if you split that power G power small I into Z of G, and if you simplify that step, so G power small J into Z of G for some small J. So from this step, okay, from the first step you can write A into Z of G is equal to G power small I Z of G. Okay, from this step you can write this value. Okay, A into Z of G is equal to G power small I into Z of G. Why? Because there is equality relation between them. So from this condition you can write that A is equal to G power small I into small z suffix 1 for some z suffix 1 belongs to capital G. Okay, so therefore similarly from second equation you can write b into z of g is equal to g power small j into z of g. From this condition you cannot, no need to cancel z of g. Why? Because their z of g is the center of the group g, that is the group. You cannot able to apply the cancellation loss, so you have to write directly b is equal to g power small j into z suffix 2 for some z suffix belongs to any element in the center of the group g. So these are the equations for A and B. So now by using equation number 1 and equation number 2, so we are going to prove that capital G is an abelian. So consider, I am considering A into B, product of A into B. We have to prove that B into A. So A into B is equal to substitute the A, B values, okay, from equation 1 and equation number 2. A value is that one and B value is that one. And then now you have to simplify them to get that B into A. Since by the definition of Z of G, the elements of the center Z of G commutes with all the elements of the group capital G. Now that's why we are proving in the format of the commutative property format by applying associative condition also. So therefore G power I into G power J into Z1 Z2. Next G power I plus J. That condition again you are writing G power Z plus I. Okay, again so we are splitting. So G power J into G power I into Z2 into Z1. So again we are separating each and every term, so to get b into a. So therefore g power small j into z2 into g power small I into z1. So from equation number 2 this value is b, from equation number 1 this value is small a. So therefore LHS a into b is equal to RHS b into a. So this is the pure condition for the commutative property. A into b is equal to b into a whenever a comma b belongs to capital G. So therefore G is commutative, automatically G is an abelian group. So therefore ఈ కండిషన్ ని మనం ఎందుకు ప్రూవ్ చేసామంటే సైక్లిక్ గ్రూప్ అని తీసుకున్నాం కదా, సైక్లిక్ గ్రూప్ కండిషన్ ని సెంటర్ ఆఫ్ గ్రూప్ కండిషన్ ని రెండింటిని మిక్స్ చేసి సో ఈక్వేషన్ 1 ఈక్వేషన్ 2 ఫార్మ్ చేసాం. విత్ ద హెల్ప్ ఆఫ్ ఈక్వేషన్ 1 ఈక్వేషన్ 2 ఓన్లీ వి టుక్ ద కండిషన్ ఆఫ్ ద కమ్యుటేటివ్ ప్రాపర్టీ, దెన్ LHS is equal to RHS. Therefore G by Z of G is cyclic అయినప్పుడు సో కంపల్సరీ G is an abelian group. This theorem is also very important for the examination purpose. So make a perfect practice, prepare well. Until bye. Thank you.